Have you ever tried to push a heavy object and noticed it doesn't budge at first, but once it starts moving, it's much easier to keep it going? That's all thanks to two types of friction, static and kinetic friction. Static friction is a force that keeps an object stationary when you apply a force. Think of it as a glue between box and the floor. This friction increases with the force you apply up to a point. The maximum static friction is what you needed to overcome to make the object move. Once your applied force exceeds this maximum static friction, the box moves and static friction is no longer in play. Now that the box is moving, kinetic friction takes over. Kinetic friction is generally weaker than static friction, which is why it's easier to keep the box moving than to start moving it. Unlike static friction, kinetic friction has a constant value and doesn't depend on how hard you're pushing, only on the surface material and the weight of the object. So, why does friction happen? Surfaces may look smooth, but under the microscope, they're rough and jagged. These tiny bumps interlock, creating resistance. With static friction, these bumps are locked together, requiring more force to break free. In kinetic friction, the forces slide over each other, creating less resistance. The amount of friction depends on the nature of the surfaces and the force pressing them together. This is represented by the coefficient of friction, a value unique to every surface combination. Friction is everywhere, helping us walk, drive, and even write. Engineers consider friction when designing everything from car tires to sports gear. Understanding static and kinetic friction helps us solve problems and improve how we interact with our environment. So, the next time you push or pull or slide something, remember, friction's got your back and sometimes your resistance.